In a world increasingly reliant on connectivity, vast portions of the globe remain excluded from high-speed internet. Enter Starlink, a revolutionary satellite internet initiative by SpaceX, founded by Elon Musk. Starlink's mission to provide high-speed, low-latency internet access to every corner of the planet, especially underserved areas. Imagine a world where individuals in remote villages can access the same online resources as those in metropolitan areas. Traditional satellite internet relies on geostationary satellites, positioned far above Earth. This distance introduces latency, making activities like video conferencing and online gaming nearly impossible. Starlink deploys a constellation of low Earth orbit (LEO) satellites much closer to Earth. This strategic placement minimizes latency, providing a significantly improved user experience. For those long-awaiting reliable internet, Starlink is not just a technological marvel, it's a gateway to a world of opportunities. By extending the reach of high-speed internet, Starlink has the potential to transform lives and empower communities. Starlink's magic lies in its constellation of thousands of small, mass-produced satellites orbiting Earth at a much lower altitude. These satellites work in unison, creating an interconnected web that beams internet signals between space and ground. As one satellite passes over the horizon, another seamlessly takes its place, ensuring continuous internet coverage. This intricate ballet in space is made possible by cutting-edge technology and innovative engineering. Each satellite boasts 4 powerful phased-array antennas, enabling them to direct internet signals with laser-like precision. Furthermore, Starlink satellites are interconnected through a network of laser links, enabling high-speed data transfer between satellites. This inter-satellite communication system significantly reduces the need for ground stations and further minimizes latency. The result is a seamless internet experience, even in the most remote locations. Starlink's reliance on LEO satellites offers several key advantages over traditional geostationary satellite internet. The most noticeable advantage is reduced latency. Thanks to the significantly shorter distance between the satellites and the Earth's surface, this lower latency is crucial for real-time applications, making activities like video conferencing and online gaming much smoother. Another benefit of LEO satellites is increased internet speed. By placing satellites closer to Earth, Starlink can achieve faster data transmission rates compared to traditional satellite internet. Moreover, the LEO constellation provides wider coverage, reaching areas often neglected by traditional internet providers. Starlink's satellites are constantly orbiting the Earth, ensuring that even the most remote regions have access to high-speed internet. This innovative approach has the potential to revolutionize how we connect to the internet, particularly in underserved areas. Each Starlink satellite is a marvel of modern engineering, packed with sophisticated technology designed to deliver high-speed internet from space. At the heart of each satellite lies a powerful phased-array antenna system, consisting of 4 flat-panel antennas that can electronically steer their beams. This advanced technology allows the satellites to focus their signals on specific areas, maximizing efficiency and minimizing signal interference. To propel themselves and maintain their precise orbits, the satellites are equipped with krypton-powered ion thrusters. These highly efficient electric propulsion systems provide gentle but continuous thrust, allowing the satellites to adjust their altitude and avoid collisions. In the unforgiving environment of space, collisions are a constant threat. To mitigate this risk, Starlink satellites are fitted with an autonomous collision avoidance system. This sophisticated system uses onboard sensors and advanced algorithms to detect potential collisions with other satellites or space debris. If a collision is imminent, the satellite automatically maneuvers itself out of harm's way, ensuring the safety and integrity of the entire constellation. Please like and subscribe to our channel for more updates. Accessing the Starlink network is surprisingly straightforward, requiring only a Starlink kit and a clear view of the sky. The Starlink kit consists of 3 primary components: a phased-array antenna dish, a Wi-Fi router, and all the necessary cables and mounting hardware. The dish is designed for simple self-installation and features motors that allow it to automatically orient itself for optimal signal reception. Once the dish is installed, it automatically connects to the Starlink network, searching for the nearest satellites overhead. The Wi-Fi router, included in the kit, receives the internet signal from the dish and transmits it wirelessly to devices within the user's home or business. The router also features a simple and intuitive interface for managing the network and monitoring signal strength. Unlike traditional internet providers, Starlink offers a straightforward monthly subscription with no long-term contracts or data caps. This flexible and transparent pricing model makes Starlink an attractive option for users seeking reliable, high-speed internet access. From the self-orienting dish to the straightforward service plans, Starlink aims to make high-speed internet access as accessible and hassle-free as possible. Starlink's entry into the internet service market has shaken up the industry, challenging traditional providers with its promise of high-speed, low-latency internet access. Compared to traditional internet services like fiber, cable, and 5G, Starlink offers distinct advantages and disadvantages depending on the specific location and user requirements. In terms of speed, Starlink sits comfortably between cable internet and fiber-optic connections, offering download speeds that can reach several hundred megabits per second. While not as fast as high-end fiber connections, Starlink's speeds are more than sufficient for most online activities, including streaming, gaming, and video conferencing. Where Starlink truly shines is in its latency, which is significantly lower than traditional satellite internet and even rivals that of some fiber connections. This low latency is a game changer for real-time applications, providing a smoother and more responsive experience for online gaming and video conferencing. However, Starlink's biggest advantage over traditional internet services is its global availability. Unlike fiber and cable, which require extensive ground infrastructure, Starlink can reach even the most remote and underserved areas as long as there's a clear view of the sky. Starlink's potential applications extend far beyond providing internet access to homes and businesses. Its global reach, high speed, and low latency make it an ideal solution for a wide range of industries and scenarios. Rural areas. Starlink is a game changer for rural communities that have long been underserved by traditional internet providers. Its satellite-based technology can reach even the most remote areas, providing high-speed internet access for education, healthcare, businesses, and entertainment. Disaster relief. In the aftermath of natural disasters, communication infrastructure is often damaged or destroyed, hindering relief efforts. Starlink's rapidly deployable satellite internet system can provide vital communication links for first responders, aid organizations, and affected communities. Maritime and aviation sectors. Starlink's low latency and global coverage make it an ideal solution for providing high-speed internet access to ships at sea and aircraft in flight. This enables real-time communication, navigation, entertainment, and remote monitoring capabilities. Despite its revolutionary potential, Starlink faces several challenges that could hinder its widespread adoption and long-term success. High costs. The initial cost of the Starlink kit and the monthly subscription fees can be prohibitive for some users, particularly in developing countries. SpaceX is actively working on reducing costs through technological advancements and mass production. Signal obstructions. Starlink satellite signals require a clear line of sight to the sky, which can be obstructed by trees, buildings, and other obstacles. This can limit its availability in densely populated urban areas and heavily forested regions. Space debris risk. The deployment of thousands of Starlink satellites has raised concerns about the increasing amount of space debris in Earth's orbit. SpaceX is implementing mitigation strategies, including deorbiting satellites at the end of their life and equipping them with collision avoidance systems. Bandwidth limitations. As more users join the Starlink network, the available bandwidth per user may decrease, potentially leading to slower speeds during peak hours. As Starlink navigates these challenges, its potential to transform global connectivity remains undeniable. Imagine a world where remote villages can connect to the internet for the first time, where natural disaster zones can quickly regain communication, and where every student, no matter their location, has access to the same educational resources. The future of Starlink is not just about faster internet speeds or lower latency, it's about bridging the digital divide and creating opportunities for millions of people around the globe. SpaceX's commitment to innovation and problem-solving means that even the toughest obstacles can be overcome. As we look to the horizon, the promise of a more connected world seems within reach. With every satellite launch, we get one step closer to a future where information and communication are accessible to all, regardless of geography. Thank you for watching. If you enjoyed this video, please leave a comment below and let us know your thoughts. Don't forget to like and subscribe for more content.